Okay, today we're doing extra limits of combination and compositions of functions. Combinations when you're like adding two functions, and then you can just find the limit of each individual one and add the results. Compositions when you're composing them and you're finding the limits, and you can compose the limits and then find the result that way. You're allowed to combine and compose functions as long as the limits exist. If the limits do not exist, then that makes it a little trickier. So these are all combinations and compositions where finding the result is a little bit trickier or less straightforward than usual. Let's look at example 1. It's the limit as x approaches 1 of f of g of x. So I'm going to apply the limit as x approaches 1 to the g of x. Which graph is g of x? This is the graph of g of x. Okay, so limit as x approaches 1 is, 0? Okay, because this is a composition of limits, now I don't say f of 0, I say the limit as x approaches 0 of f of x. Okay, and then the limit as x approaches 0, let me look at the f of x graph. The limit as x approaches 0, it looks like that's going to be 2. Okay, so this one turned out great. Everything existed and I did the composition. Okay, let's try the next one. This one is the limit as x approaches 2 of f of x plus g of x. Okay, let me see what the limit as x approaches 2 of f of x is. The limit as x approaches 2 of f of x is problematic because it does not exist. If it doesn't exist, I can't do doesn't exist plus something else. And it doesn't mean it doesn't necessarily have an answer. It means we need to check more carefully. And the way we check more carefully most of the time is we check from the left and the right. So let me find the limit as x approaches 2 from the left of f of x plus g of x. And then also from the right. And you feel like it's going to fail no matter what. And it might still fail, but we have to at least give it a chance to see if it. Okay, the limit as x approaches 2 from the left of f of x. F of x is up here. At x equals 2, if I'm coming from the left, it looks like I am approaching 0. 0 plus, now the limit as x approaches 2 from the left of g of x. G of x is down here. Here's 2. If I'm approaching 2 from the left, I'm approaching 3. So 0 plus 3 is 3. Now let me check the limit as x approaches 2 from the right of f of x plus g of x. Okay, f of x is up here. If I'm approaching 2 from the right, 2 is right here. If I'm approaching from the right, it looks like I'm approaching y equals 1. 1 plus. Okay, now I'm going to do limit as x approaches 2 from the right of g of x. G of x is down here. At x equals 2, if I'm approaching from the right, I am approaching 2. So I have 1 plus 2. Which happens to equal to 3, just like it did from the left. So it turns out the limit as x approaches 2 of f of x plus g of x is 3. Okay, so even though the individual pieces did not exist, it's possible that when you add the functions, then it will end up working again. Okay, let's look at example 3. The limit as x approaches 2 of f of x times g, parentheses x minus 1. Okay, there's a lot of things going on. Okay, limit as x approaches 2 of f of x. That's a problem because it does not exist. So we already have a problem. Now the limit as x approaches 2 of g of parentheses x minus 1 is confusing. But let me think. If x is approaching 2, and this is saying to the x minus 1, 2 minus 1, this is actually like it's x is approaching 1, even though that looks weird. Okay, now does that help us? Not totally. We still have to check from the left and the right because limit as x approaches 2 of f of x did not exist. Okay, so let me check from the left and the right and then see if they match up. Times g of x minus 1, limit x approaches 2 from the right of f. Okay, 2 as x approaches 2 from the left of f of x. Here's 2. From the left, it's going to 0. Times. The limit as x approaches 2 of g of x of 1 is the same as saying the limit as x approaches 1 of g of x. The limit as x approaches 1 of g of x is actually 0. So 0 times 0, I get 0. Okay, let's check the limit as x approaches 2 from the right and see if I can make it match. Okay, limit as x approaches 2 from the right of f of x. Here's f of x. On the right side, it's approaching 1. 1 times. The limit as x approaches 2 from the right of g of x minus 1 is the same as the limit as x approaches 1 of g of x. So limit as x approaches 1 of g of x is still 0. So 1 times 0 is 0. So the limit as x approaches 2 of f of x times g of x minus 1 is actually going to be 0 because the left and right-handed limits agreed. Okay, let's try the last two. The last two are going to be a different technique that you can use. Okay, this is the limit as x approaches 0 of f of x. So let's apply the limit to the inner function. Okay, the limit as x approaches 0 of f of x. That looks like it's approaching 2. Everything looks great so far. Okay, now I'm going to do the limit as x approaches 2 of f of x. Okay, as x approaches 2 is different on the left and right. Now, I want to see if I can narrow down which one of those answers is correct, because sometimes you can and sometimes you cannot. Okay, I'm going to go back to the limit as x approaches 0 of f of x. That was over here. The y value is definitely approaching 2. I see that the y value is approaching 2. The y value is approaching 2 from below 2, and it's leaving from below 2. So both of the times the y is approaching 2 from below 2. So it's actually approaching 2 from the negative, because it's coming from below 2. And on the right, it's also coming from below 2. The y value is. So if I think of this as the limit as x approaches 2 from the left of f of x, now when I go to the limit as x approaches 2, I can know that they're asking me to figure out this value, which is 0. Okay, now was that one hard? Yes. We're going to try one more that is similar to that. Okay, let's look at example 5. The limit as x approaches negative 2 of f of g of x. Okay, let's just start it off like everything's fine. The limit as x approaches negative 2 of g of x. So this is g of x. The limit as x approaches negative 2. Well, it looks like the y value is approaching negative 1. Okay, so this is the same as the limit as x approaches negative 1 of f of x. Okay, now let's go back to f of x and see what the limit as x approaches negative 1 is. Oh no, it doesn't exist because it's different from the left and the right. So it's very possible it does not exist, but if possible, we want to figure out if it's approaching the negative 1 from the negative or positive side so that we can decide which one it's actually going to be. Okay, so let me go back. The limit as x approaches negative 2 of g of x. That's over here. Okay, the y value is approaching negative 1 for sure. I see it's approaching it this way, and it's approaching it this way. The y values are approaching negative 1 from above the negative 1 on that side, and the y value is approaching negative 1 from above the negative 1. So this is actually approaching negative 1 from the positive side. Okay, now if I know that that y value is approaching negative 1 from the positive side, now I do the composition. I can do the limit as x approaches negative 1 from the positive of f of x, and it tells me which of the values to use. So at negative 1, the positive is this one up here, and that looks like it's about 1.5. So this is going to equal to 1.5. Okay, and then this is only what you try when parts of the composition or combination don't exist. Normally everything turns out great and you can get the answer with no problems.